Example 2 has us solving for a first-order differential equation. So it says find y given dy dx equals x root 2x plus 1. Okay, so the first thing I'm going to do is I'm going to separate my differentials. So I'm going to multiply the dx over. So I get dy equals x root 2x plus 1 times dx. So I'm going to separate, and now I'm going to integrate. Okay, so on the left-hand side, what's the integral of dy? Or think of it as 1 times dy, and you get just y. And now, on the right-hand side, this is going to be another U-substitution question. So again, just like with the last example, look for a composition of functions, right? I have 2x plus 1 inside my radical here. So I'm going to come over to the side here, and I'm going to let u equal 2x plus 1. So take the derivative with respect to x. So I get du dx is equal to 2. And I'm going to go ahead and separate the differentials there. So I get du equals 2 dx. But I actually want to solve for the dx here, right? And so I'm going to get 1/2 du is equal to dx. So a couple substitutions I'm going to make here. So u is equal to 2x plus 1. And then dx is equal to 1/2 of du. So I can substitute that in as well. Now, similarly with example 1, right, I still have this x in front of my square root here, right, which is not getting, kind of substituted in with my substitutions for u or dx right now. So I'm going to do the same thing I did last time, which is I can take my U-substitution and rewrite it so that I can get the x by itself. So I'm going to write u minus 1 over 2 is equal to x. So I'm going to substitute that value for x into my integral. Okay, so I'm going to end up doing 3 total substitutions here. Okay, so let's go ahead and substitute everything out. So x, again, I'm replacing with u minus 1 over 2. Okay, inside the radical was 2x plus 1. That is u. And then the dx is becoming 1/2 du. So 3 substitutions in total taking place here. Okay, so once I have everything here in terms of u, right, now I can go ahead and kind of simplifying my integral here a little bit, right? So I'm going to start with taking the 1/2 away from the du and bringing it outside of my integral. And now I'm going to go ahead and distribute the root u, and oops, I'm sorry, there was also another half, right, in the x substitution, u minus 1 over 2. So I'll bring that 1/2 out as well, and that gives me 1/4 in front of my integral. Now I can go ahead and distribute root u, or u to the 1/2, into u minus 1. So if I do that, I get u to the 3/2 minus, and I don't like that u, so I'm going to redo it, u to the 3/2 minus u to the 1/2 du. Okay, and now this is all power rule, right? So I'm going to leave the 1/4 out there for now. U to the 3/2 antiderivative is going to be 2/5 u to the 5/2 minus u to the 1/2 antiderivative is going to be 2/3 u to the 3/2, and then don't forget plus c. Now some of you might be wondering, why is the 1/4 parentheses closed there before the plus c? Shouldn't the plus c be in that parentheses? And technically you'd be right. If I move this here, right, that's technically what it should be, right? But remember, what is 1/4 times a constant value c? Well, it's still just another constant, right? So I think it's easier just to do the plus c ultimately at the very end, okay? And now that I have this integral, right, I'll go ahead and distribute the 1/4, and then I will substitute back out for u. So 1/4 of 2/5 is 1/10, and then my u substitution is quantity 2x plus 1, so that will be to the 5/2 power. 1/4 times 2/3, so this will be minus 1/6, the quantity 2x plus 1 to the 1/2 power, and there's my plus c at the end. And that is my final answer.